Hello everyone, my name is Iman Ghali. I am the second course of the University SDU. Today I am going to solve about electric field flux. And about electric flux, I want to tell about interesting concept in electrostatics, how the electric flux of the point charge through any surface related to the solid angle that the surface substance at the charge. By the end of this, you will see the simple way to understand these relationships. And as we see, we have the one question and I want to explain it. And the question about the proof that the electric field flux of the point charge Q through any surface is equal to the solid angle at which this surface is visible multiplied by this formula. And in this case we have electric flux is equal to, as we have a charge over 4 pi epsilon 0 multiplied by solid angle, and we're gonna prove that it's correct. And as we see in the picture, we have the one charge Q in this point and one surface. As we see, this surface and electric field and this angle, solid angle. And I think we can start it with electric flux. Imagine we have a small light bulb in a dark room like this. The light spreads out in all directions. Like this. And now you hold a small hoop in front of the bulb, like in a small area. It's a surface. Some of the light will pass through it, like from all of this surface area. The amount of light that goes through depends on how big the loops, how area is big, or hope is how close it into our light. In this case, with this example, we can say that our electric flux is works the same way like lights, but we can change light to our charge Q, and we can electric field coming from a charge. The flux tells us how much of that electric field passes through a surface. For example, we have our charge in the same surface area, and we have the electric field, and with electric flux we can find a field passes through this surface area. And the closer or bigger the surface, the more field it captures, meaning more flux. And we have the formula is mathematically, we can write electric flux is equal to integral of electric field multiplied by dA. This is the main formula of electric flux. And the second, I want to talk about Gauss' law. Now let's talk about important rule, Gauss' law. It tells us that if you place a charge, like you can put charge inside of the surface, like one surface, and charge is inside of the surface. The total electric flux, our electric flux total, is equal to our charge over epsilon 0. It's when it's inside a surface. This means that no matter what shape this surface is, as long as it's completely around the charge, the total flux is always the same. For example, imagine a sphere. We can change the surface with sphere. You can one sphere. And inside of this you have the charge, and this is totally the same formula. But what if you only look at small part of sphere? For example, we can take this part of sphere in surface, and that's where the solid angle have. And the third step, I want to, in this case, talk about solid angle. It's, for example, we can, in this case, take two situations. It's like, imagine it's our eyes, and it's piece of paper. In our eyes view, it's blocked with this paper, and we can see behind the paper. It's like this area. But if you throw the smaller surface, like say the same paper in the long distance, this paper blocked is a smaller area than the first situation. We can like this. I think it's understand. You can just remove it. It's like one example. And for a full sphere, that a solid angle is always, it's when it's a full sphere with our solid angle is equal to, is total 4 pi. And now comes the key idea. Since the electric field is spread evenly across the sphere, the flux through any smaller surface is just a fraction, and we can just take one small area of this, and the flux corresponds to the friction of the sphere covers. We can just solid angle divided by 4p, like this. And after that all, so the flux through a smaller surface simplifies as friction multiplied by the total flux. And last one, we can write this. Our flux is equal to solid angle divided by 4 pi multiplied by flux total. As you know, flux total is in this case. Just put it and solid angle divided by 4 pi times our charge divided by epsilon 0. We can simplify it, and our flux is equal to charge divided by 4 pi epsilon 0 multiplied by solid angle. And we just prove it that it's a correct solid angle at which his surface is visible multiplied by this formula. I think it's understandable, and that's exactly what we wanted to prove. I think it's more easier than we think. In conclusion, I want to say about two things. First thing is our electric flux. It measures how much the electric field passes through a surface. For example, with a surface, and our electric flux measure how much our electric field passes through this surface. And the second, our solid angle is how much our charge surrounding a surface covers, acting this surface. and the flux through any surface is just solid by multiplied by our flux is equal to like our solid angle multiplied by q 4 pi epsilon 0, and it's the final formula. I think its explanation made the concept clear. I hope no one has a question.